So question 4 and 5 are based off this graph. And so let's analyze the type of graph. This is velocity versus time. So as time proceeds, then velocity has some kind of value according to also which car you're looking at. So for car A, velocity is v0 all the time, for sure between 0 and 20 seconds. Whereas instead for car B, velocity is increasing steadily between 0 and 20 seconds, starting from 0 to whatever value the velocity is up here. So, which one of those statements is true? Well, if you read carefully, you see that they are stating car B is behind car A, in front, passing. So obviously they are talking about, at least for A, B, and C, they are talking about positions, right? Whereas for D, they are talking about the same accelerations, and E is also talking about acceleration. So let's see how you approach those kind of problems. So let's say that, for example, when you look at so let's say we're looking at the car A, right? And for car A, we can say that V is equal to V0 all the time, right? So for example, it's a fixed number, let's say 7 meters per second. And this is between 0 and 20 seconds, right? Whereas instead for the car B, what can we say? Well, for car B, we can say the velocity initially, so at time 0 is equal to 0 meters per second. At time 10, so V10, right? So when t is 10, this is where the V for the B is, so is V0, and then keeps increasing. So from kinematics, you know that if V is constant, right, then that means you're not accelerating, right? So this takes out the equation, the answer D, because they have the same acceleration. Well, this one has a constant velocity, so no acceleration. This one is actually changing velocity from 0 to V whatever. So obviously imagine yourself in the car. So if you are changing your velocity from 0 to a different value, obviously you are accelerating. So in this case, for A is not accelerating because of constant velocity, right? You're not pushing on the pedal, the accelerator, more or less, right? You should keep it constant. So acceleration is 0 in this case, whereas in this case it's not, so they do not have the same acceleration, and also takes out E because car A is accelerating faster, so there's no acceleration at all in A, so D and E are not working fine at all. So let's keep focusing now at this position instead. So if you're looking at positions, right, when you actually have velocity, so you know the position is the integral of the velocity itself, right? So you integrate the graph for the velocity or the function of velocity, and you come up with the idea of, with the expression for x instead for the position. So if your equation, right, is v equal v0, so this value is just a constant, right? Then, so pay attention to your graph. That's your velocity, this is your time, right? And you're looking at this portion of v, so this is your v0 between 0 and 10 seconds. So being x, the integral of v0 in dt, right? That's just a constant. So this is v0, doesn't get integrated, so this is the integral of dt, which we know is v0 times t, and this is between 0 and 10 seconds, right? So that will be your expression for x. Also, you know that this is the area coincides with the area, right? Because it's v0, which is your value here, right? So this is v0, which is the height, times the t, which is this. So multiplying those two dimensions, this is your rectangle. So this is the area of the rectangle, okay? So this whole thing, this whole number, okay? So when you multiply V0 and 10, this will be, right? So V0, 10 times V0, let's put it that way, is going to be your value, okay, for the position of A. What happens instead to the car B? So that's the graph. And between 0 and 10, right? Now this instead is the graph that you're looking at, right? This triangle here. So you know, so this is for A. For B, you know that velocity is not a constant, right? But is a line with a constant slope, right? So this means that the slope is constant and is V0 over this, so whatever slope you have, right? So let's call it M. I think you call it M in math, right? M times T. So this is the expression of this particular graph. Again, to calculate your x, you got to integrate this mt dt. So you can take out m because it's just a constant. So that would be your integral of t dt, which means it's 1/2, right, mt squared. Okay, so now notice you have 1/2 of the m and the t squared, right? So this means that this instead is the area of your triangle. Do you see? It's 1/2 base times height. So when you have this, now you're looking at this portion here. So which one is smaller? Is smaller this value, the x for B, or the x for A? Obviously looks like the x for B is smaller than the x for A, which means also the B, right, has traveled a lesser distance, right? So B cannot be ahead of A, has to be, and it's not even equal, so B, right, is behind A. Okay, and that would be your answer. What happens instead, so the next question, right, they say, okay, between 0 and 20, the areas above, under those curves are equal. So what is true? Well, so go back here. Now, if the area, right, here is the same as this, right? So let me draw it for you. So you're looking at this graph here. So you have this big triangle, and you have this rectangle instead. Well, this is definitely not it. So you have that one, and you have this. Okay, so let's compare those areas. Okay, they are saying those areas, so this area here and this area here, they are the same. So if the red area is the same as the black area, that means x, so the distance traveled by B is the same as the distance traveled by A, but also B is right here and is keeping on going at that point. So this means that B is actually passing, right? Because right now is car B and car A at the same line, at the same distance, right? But B is keeping on going because it's still accelerating, so B is passing car A. Okay, so that would be your answer.